Hello, my name is Keith Rucker, and today we got another interesting project for you, and it seems like every time I get working on one thing, something else comes up that we need to take care of. And this is actually related to the Steam Powered Sawmill here at the Georgia Museum of Agriculture. And this sawmill was built back in the late 1890s originally, and has been operating here at the museum since probably the mid 1970s. So as you can imagine, it's got a lot of wear on it. And we've recently gotten the sawmill. It was down for about 5 years, I guess, because of our having some issues with our boiler. But we got it back up and going here in the last 6 months or so, and have been starting to run it fairly regularly. And we've noticed we got a little problem with one of the clutches it's basically a variable speed clutch mechanism, pretty low tech, and we'll show you what it all looks like later on, that controls the carriage, the forward and reverse, and then adjusting the speed. So as that log is going into the blade, you can adjust how fast it's going in there and then move that carriage back and forth. So they came out here and actually went ahead and pulled everything off before I got a chance to get any videos of it. But again, we'll look at it, the completed thing, so you can get a better idea. In fact, I may have a picture of what it looks like that I can throw in here. I'll have to dig around and see if I do. But basically, you got a shaft here, and it has this piece here, and this is actually sandwiched with a paper pulley in there. And this pulley runs up against a flat disc, and by sliding this on this shaft back and forth, you can adjust the speed of the carriage and the direction of the carriage depending on which side of the disc you're running onto. So anybody's familiar with an old snapper lawnmower, basically the same type mechanism that was on the old snapper lawnmowers years and years ago. So here's the deal. This is the hub that slides on the shaft and goes back and forth, and this is the shaft. And this shaft is originally 1 5/8 inches is what the nominal size of it was. But the problem we have is over the years, the bore in here has actually worn out, and it's not an even wear. It's actually kind of at a taper in there. There's more pressure on this end, so it's kind of worn lopsided, I guess. And but it's anywhere from about 30 thousandths oversized up to about 60 thousandths oversized in this bore, and that's given us some slop on there. That's given us some problems. And additionally, the shaft here is worn as well, particularly in the area that this thing is moving on a lot. And it's about, depending again, I mean, if you get out here on the ends where there's hardly ever on there, it's right on the money. You get in this area here where there's a lot of movement going back and forth. It's anywhere from 5 thousandths to 20 thousandths undersized. So anyway, we need to take care of this issue. We need to get the slop out. And also, while we have it apart, we're going to put a new paper pulley in here, and we'll get into how we're going to do all that later on. But right now the challenge is, and I've been sitting here really studying this, trying to come up with a good game plan on how to do this. So my first thought was, when it was still on the sawmill, just looking at it, I said, well, we'll pull it off and we'll bore out the hub here and put a bushing in there, and put it all back together. But as we get it apart and I really get to looking at how it is, I'm really concerned that if I bore this out enough to put a bushing in here, because this is a keyed slot in here. There's a keyway, and that's what keeps it on there. I'm going to need to take it out bigger than the keyway, and then I'm going to have to put another keyway in there, and I'm going to have to key both the bushing and the on the outside and on the inside. So it's going to have to bore out a lot of material to put a bushing in here. And because of this diameter here being cut down, which a collar fits over, I'm really concerned that we're going to be hurting the integrity of this piece if we try to put a bushing in it. So I think now my plan is that instead of doing that, we're already going to have to make a new shaft as well, because it's worn. So I think what I'm going to do is I'm going to bore this out just enough to clean this up, to get a good bore in here, and we'll figure it out what diameter that is. And then I'm going to make a new shaft, and we'll turn the ends down to the 1 5/8 inches where it runs in the bearings, and where it has a gear that goes down here. But in the center, we'll actually turn that to a diameter that's just a few thousandths under. Well, probably 7 or 8 thousandths under because it needs to be able to slide laterally on there pretty easily. So we'll turn this down a little bit smaller diameter than the bore. So anyway, I think that's what I'm going to do now, rather than just using a nominal size shaft, which was my initial intention. So anyway, a lot of parts here. Most of these we're really not going to fool with as far as doing any work to, but we are going to go ahead and get this hub. And first thing we're going to do is we're just going to have to get this bored out. So I'm going to take this over to the lathe. We're going to mount it up in the 4-jaw chuck, get it running true, and bore this out and see what it takes to get it to clean up. So I've got this pulley piece here on the lathe now, and we've got it chucked up in the 4-jaw chuck, backed up against here. You know, I took my lead hammer and tapped that up so that this back side, it's not a machine surface on this side, but it is fairly flat, and that is kind of my reference that I want to, because we'll be stacking the paper up on this side. And we do have this machine surface in here that this little collar fits on, and I did check the diameter around it, and it appears to be running, or it appears to be the same diameter all the way around, so it is a true round piece, and I've just indicated off of that. And you know, we've got this running within about a 1/2 thousandth of run out, which is going to be more than adequate for what we're doing here. I'm very pleased that I'm able to get it running that true. I will admit that it takes me a little bit longer to dial one of these things on a 4-jaw chuck than my buddy Adam Booth, but it's not a difficult process, and we've got this running true now. So I think we're ready to go ahead, put a boring bar in here and start boring this out. So we got this bored out now to 1 3/4, and just to kind of give an update on our plan, I found a piece of 1 3/4 cold roll shaft that we're going to turn the new shaft out of. And so instead of trying to turn down the fit, we just decided to go ahead and just make it fit the nominal 1 3/4. And this is just a little short piece of that shafting that I had, and you can tell, you know, we've got a nice slip fit in there, which is exactly what I want, because this this piece here is going to be sliding on this shaft, and you know, I think there's about 6/1000 clearance in there right now, so the bore is about 6/1000 over the shaft, which is, I'm hoping, going to be just right. In addition to the big pulley flange that we just got through machining, there's also a second piece, and this is just a little bracket that slides on that same shaft, and we need to bore it out as well. This piece here is really badly worn. In fact, it's probably not going to totally clean up even taking this up, but what I've decided to do, rather than trying to indicate it in, it's really worn oblong in there in 2 different directions where the pressure's on it. So I've just put it in here in a scroll chuck and got it centered up on the rough casting, and we're just going to bore this out as close as we can. And part of it is going to be a little bit oversized, but it's just too thin to try to put a sleeve in and bush it down. So we're just going to do the best job we can, and down the road I'm probably looking at casting a new one of these and replacing it probably next time we take this off. So we're already started the process of getting a pattern made for it. So let's go ahead and knock this one out. getting ready to start turning down the ends of the shaft. So the shaft is 1 3/4 nominal size, and we're going to leave that, but we need to take the ends down where the bearings are going to go in, and there's a gear on one end that needs to go down to 1 5/8. So the shaft is a little under 5 feet long. I think it's 52 or 56 inches. I can't remember exactly. I've already got it cut off to length. And what I did is the 1 3/4 will just barely fit up through the spindle of my lathe, which is perfect. And I've got it in here. Actually, that's as far in as it would go right there, which was just fine. And I took my indicator, got the shaft running, and the 4-jaw chuck within about 1/1000th of an inch was about as good as I could get it. Just working off that cold roll finish. And anyway, we got that on there, and I've just drilled a center drill in here. Now what we'll do is we'll go ahead and slide this out the mount that I need to turn down, and we'll support the end with a center. On this end of the shaft, we need to turn about 10 inches down to 1 5/8, and you know, we indicated this in, drilled the center. I've already indicated down here I'm running within 1/1000th on the end, and also here we went ahead with the 4-jaw chuck, and on this end, you know, I'm running within about 1/2,000th. So I'm real happy. You know, this should be great for this shaft. What we're going to do now is just turn this down to the right side. So the shaft is all turned now on the lathe. We got the center section here. Did it off camera, but I just put it in there and just took some emery cloth and just kind of polished the section here that the wheel will be sliding on. And of course the ends are turned down to the proper length or proper diameters. Now we need to cut a big long keyway, 3/8 inch keyway in the top here that pulley will rotate or slide on. It's keyed so that it will turn with the shaft. And then we also need to put a little 3/8 inch keyway down here on the end of the shaft for the gear that will engage onto the sawmill carriage. So I'm going to do this on the horizontal mill. I like cutting keyways on the horizontal mill, guys. It's easier, quicker, I think faster. Some people have said, well, you got all the setup time, it's too slow. Well, it is a little bit more troublesome to put the cutters on the arbor, but it's not a big deal. It's not a big deal at all. In fact, it really doesn't take much longer than putting an end mill in the vertical mill. And with the power feed that this thing has and being able to take it all in one pass, in the end of the day, I would argue that it's almost faster really to do it on the horizontal mill. And it's something that I can just walk away from and let it do it on its own, rather than me have to sit there and watch it like I do on the vertical mill. So, you know, I've talked about my horizontal mill before and setting these up, but I'm going to just briefly go over, you know, getting this thing set up. It's a pretty simple job. We're just going to put a single cutter on here. This is a 3/8 inch keyway cutter. I've got in my my 1 inch arbor, or 1 inch arbor. I think that's what this is. And you know, it's in here. Everything's on tightened up with the 50 taper in here. Pretty simple. Slide it in, just tighten the screw up on the back. I did take a couple of minutes and just really, and this is something you should do anytime you put these arbors on your machine. Take a few minutes and clean them real good. If it's like most shops, if it's like mine, these arbors are going to sit on a shelf somewhere. They get covered in dust. So just take a couple of minutes, wipe them down real good, and make sure they're clean. And I usually put a little thin layer of oil up in there on the socket side just to help protect it. And on this one, I actually came in here. This arbor is old, and it's not perfectly flat or smooth across here. You can feel there's some wear on here where it feels like some bushings may have spun at one time or another. You know, it works fine, but it's not great. So I actually took a little piece of sandpaper and I just kind of polished these out. It was something that needed to be done, and took some of those rough spots out. And then I just put a thin layer of oil on this to just protect it. And now I've got a bucket down here with spacers in it, and you know, we're just going to start building our arbor. So you know, there's a keyway. You can't see it, it's back behind it, but there is a keyway on here. So we're just going to come in here, and you know, this one here is pretty simple as far as how we're going to set this up, because there's really not it's really not critical where the cutter is on the shaft. We're gonna move that. Now if you had multiple cutters, you had to get them spaced just right, it'd be different. But for this, you know, we're just going to put this on here. You know, hey, that's out far enough. I'll take my cutter, put on here, make sure I got it going in the right direction. Again, that cutter is keyed on the shaft so it won't spin. And then we're just going to put some more spacers on here till we get out toward the end a little bit. And you know, I'm going to put my overarm support here, and I don't want it out too far. The shorter this span, the more rigid it's going to be. But that's enough. So the next thing I'm going to do, this is the little bearing bushing that goes on here that's going to ride on that overarm support. I'll put it right there. It doesn't matter. This is sticking out a little bit. It doesn't matter a bit. So, and we'll put a couple more spacers on here just to take up the space until I get to my threads. And now I'm going to tighten all this up. And you want to get it good and tight. All right. So now the arbor is set up. Again, that only took didn't even take a minute, so it's really not that big of a deal. So now let's get the overarm support on here to get the support out here to make this more rigid. Alright, so I need to extend out the overarm supports here, or this is on a little rack and pinion. There's a little knob over here on the side where I can extend these out. Again, when I came over to the machine today, the first thing I did, as always, is I wiped everything off real good, including these bars, and I put a little layer of oil on them just to keep them oiled. So anytime I move them in and out, I always like to put a little fresh coat of oil on there. It just helps keep everything lubricated well, where I don't have to worry about things getting rusted up or setting up in here. And again, there's a little handle on the side, and these just move out to the end very easily. And that's probably far enough for right now. Let me grab the overarm support right here, and we'll just all right, so what's happening right there is it's hitting the bearing in here, and it's not wanting to slide up on there. What I'm going to do is I'm going to just extend that out a little bit farther. I'll go ahead and put this on here and tighten this up. And now, using my lever back here, put a little oil on that bearing to start with. And now using my lever back here, I'll just pull it back on there, and you can see it just all lines up perfectly and comes back on there. So it's a little bit easier to do it that way than trying to get all three of those holes lined up at the same time. All right, with this position where I want it, now the next thing to do is I want to tighten all these rods up where they won't move. And there's two screws up, or nuts up here on the top, and we'll just tighten these up, and that will lock the the overarms where they won't slide in and out, and make this just as rigid as we can possibly get it. Alright, now I can't move these at all. Everything's locked in place. So we got a very rigid setup here. The arm is well supported. It's very rigid. Alright, and also in getting this thing ready to go, this overarm support bracket here, you know, it's got this a bronze bushing in here, and of course this is the lock nut. You may have seen Adam Booth, he had to make one for his recently, but this just screws on there and tightens that up, and you can adjust that by this screw here, and there's 12 positions around there. But up here above this is a little oil reservoir, and you can see the little sight glass in here where you can see the oil level. And what this does is it just drips a little bit of oil down on this bearing to help lubricate it. And when these things are sitting on the shelf, basically the oil will drain out of them. So we need to make sure we have some oil in this thing. So I'm just going to unscrew the cap here, and we'll fill this thing up with oil for this job. And usually you can see right there on that little sight glass. I need to replace that sight glass. All of them on this machine are, whoops. In fact, you can't even really tell the level. It's full, but it's not even registering in there. But it is full. So I'll go ahead and tighten this back up. I've replaced a lot of these sight glasses on here. Yeah, you can start to see the oil coming in the top now. It just needs to be cleaned out. It's starting to rise up. You can see the oil level starting to rise up in there. I'm needing to cut a pretty long keyway in here, about 23-24 inches long, because that shaft is, or that pulley that I'm doing is going to actually slide on this, and it needs to stay engaged in that keyway the whole length. So I've marked on my shaft where I want to start and finish, but one thing I need to kind of figure out, normally when I'm cutting a keyway, you know, it's a fairly short length, and you know, you got plenty of travel in the table. But on this cut, I'm pretty much going to be using the full length of the table. So I've come in here and just kind of pulled my table over. I mean, that's roughly to the extreme right there where it can go. And I'm just going to take a little Sharpie pen and just make a mark here on the table, roughly where that end point is. And then I'm going to go the other way as well. Get it past that stop. There we go. And that's about the extreme the other way, and that's roughly right along in here on my table. So let's see what I got to work with. So from there to there, I've got about 26 inches of travel. I need about a 24-inch keyway. So I've got this on here, and I'm just going to, we'll put the shaft down where it's in this working area to make sure I got plenty of travel to do it. So I've got the shaft clamped down to the table now, and if you see what I did here, I've just got it clamped directly to the table. That's one of the nice things about doing shafting. I see people all the time when they're doing long shafting, trying to put it in a vise and then supporting the end, you know, and then trying to get their shaft parallel. It's just super simple, guys, because these slots in the table are perfectly parallel to the cutter, and they make a nice channel. You just set it right down in there. It aligns perfectly parallel in that one of those mill slots, and then just clamp it straight down to that, and you're ready to go. And you got a super solid setup here. Instead of just one end being supported by a vise and the other out here. This way everything's down straight to the table. So my clamping toes I've got in here, and I did put a little piece of brass shim up underneath them just to protect the shaft. I don't want to mar anything up. And like I said, everything's just clamped down. It's ready to go. You know, my range is from here to here, and my slot is going to be about from here to here. So I've kind of got that more or less centered up on there where I've got a full range. And now we'll come in here and we'll get the cutter centered up on the shaft and ready to mill. one of the features that I really like about this Kearney and Trecker mill, and really horizontal mills in general, is that you got power traverse pretty much in all three axes, whereas on most vertical mills, you have to put in a servo or something to do that. It's just built right into these. So, you know, I've got a good bit of cranking to get this to where it needs to go, but instead of cranking, you know, we just come in here, get that table right where we want it. And then I can fine feed it by hand. So now comes the job of getting the cutter centered up on the shaft. And there's, again, a pretty simple way of doing this without having to get out indicators and so forth like that. So what I'm going to do is we're just going to come in here and bring our table up very slowly until we get just touching off. All right, we're touching off right there. And now going kind of left and right, I'm just going to make a mark on the top of this shaft, and I'm going to feed down just a little bit until I get it roughly the same or exactly the same thickness as the cutter itself. So what you're looking at here is you're looking straight down, and hopefully you can see this, but as I move this cutter back and forth, you can see the area up underneath there, and I've carefully done this so that it is just a few thousandths, hardly any thousandths thicker or wider than the cutter itself. And now I can just look down this and line up the edge of my cutter to the edge of that mark and look on the other side. And if it's a little bit wide, you just want to kind of get it where you have about the same amount on each side. And now this cutter is in the center of the shaft. It's that simple. And your eye is actually a very good measuring tool. You just need to, you know, you can use that to get something in line like this very easily. So now that is going to be more than close enough for what I'm doing. If we get in here and really measure this, I guarantee you it's within a few thousandths of an inch of being on the center of the shaft, which will be great. Now we need to get the keyway to depth, and you always want to start measuring that from where you have the flat across there, not from the top of it where it touches the top of the shaft, but where the shaft is, or where that it's flat across the top of that into the proper width, basically right where we have it set right now. So, you know, I could use my dial on the front of the mill and just crank up, but I've just put a dial indicator on here. It gives me a little bit better view of what's going on. So the keyway is 3/8, and we need to go half of that depth, which will be 3/16, which is 0.1875. So we'll just start our cutter up here, and very carefully we'll plunge this in. $60, $70, $180, that's about 7.5, and I like to go a couple thousandths deeper, so we're just going to take it to 190 thousandths. So that should be the proper depth right there. All right, I think we're about ready to start milling. I've got my cool mist set up on here to kind of help provide some coolant, and you know, this is just with the regular old Formula 77 cool mist oil in there mixed in the water soluble oil. Ideally you'd use flood coolant for this, but this mill has flood coolant capabilities, but I just haven't ever got it set up. So that's something that's on my list of things I want to get done, but right now I'm just not set up to do that. So we're going to, the next best thing to do the cool mist. So let me get this going. All right, we've got a steady stream in there going. So now we'll start our cutter. My speed on this is 93 RPMs. And to start with, I've got my feed on 1 inch per minute. and we will play around with that. We may try to go a little bit faster than that as we go through here, but let's go ahead and we'll start feeding. And that's cutting like butter, making a nice chip. I'm going to inch my feed up a little bit, go to 1 3/8. We're just going to play around with this and try to get the maximum out of this we can without pushing it too hard. All right, we've got one more little short keyway to cut on the end down here where the gear is going to go up on the shaft. And I just flipped the shaft around, and just a little bit about this setup. We're getting ready to plunge into the depth, and I'm going to actually start outside the cut. But if you remember, we turned this end diameter down about a 1/16 inch smaller diameter than the rest of the shaft. And because of that, you know, it wasn't touching the ways down here, and we're getting a lot of vibration in this part while we're cutting it. So I just took a couple little pieces of brass shim and put them up underneath that and clamped everything down good and tight, and that should give me hopefully enough support up underneath this piece to keep that from chattering and ringing a little bit too much. So I didn't have to worry about refining the center because I didn't move it. It's still the same center. I touched off again, and now we're getting ready to plunge down to our depth, and we'll make this final cut. That pretty much wraps up the keyway cutting. I will come in here and just kind of round this edge over here, not round it over, but smooth it up so there's not a burr on there. But other than that, I think these are ready to go.